Welcome back, students. In this video, we're going to cover Module 7, Topic 3, Test for Parallelograms. This is on page 7 of the Module 7 packet. Start out with the warm-up. True or false? Says number 1 for our figure over here. DC is parallel to AB. Now, okay, you guys looking at this with no, with nothing spelled out for us, we're gonna just go by looks. So DC and AB, if we follow this with a ruler, these guys will eventually touch, so they are not parallel. So that's false. Number 2 says the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D equal 360. Well, we have a quadrilateral over here. We learned in lesson topic 1 that to get the total, we go n minus 2 times 180 for the measure of all the interior angles. So for this guy, it's quadrilateral, so 4 minus 2 is 2. 2 times 180 is 360. So this one is true. Put the true right here. All right, number 3, AD is congruent to BC. So AD and BC, if we get a ruler, you're going to see that these two guys are not equal or congruent. Means the same thing. Thank you for catching that. So that's a false. Now for number 4, so they say if DC is parallel, okay? So if they're parallel, and AD and BC are parallel. AD to here, BC. If those guys are all parallel, then these guys are going to be congruent. And these guys are going to be congruent because at that point, if those two guys are both parallel, this is a parallelogram, and those are equal or congruent. So number 4 is true, and it's true because if. All right, let's scoot down here. We have some theorems. So theorem 7.9 tells us that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. 7.10 says that if both pair of opposite angles of a quadrilateral are congruent, then the quadrilateral opposite angles, yes, is a parallelogram. So opposite sides, opposite angles. 7.11, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So like over here, scooch down. Didn't realize I had read off the page. So our diagonals bisect each other, so they are cut into 2 equal pieces. And 7.12 says if one pair of opposite sides of a quadrilateral are both parallel and congruent, then the quadrilateral is a parallelogram. All right, flipping over to, I'll line it up here. All right, page 8, excuse me. All right, number 1. So, if you watched the last video, topic 2, we talked about parallelograms. Topic 3 here, we're just testing. So, just more of the last video. So, number 1, determine whether the quadrilateral is a parallelogram. Justify your answer. So right here, 12 and 12 are equal or congruent. So, we have opposite sides congruent. 5 and 5, same thing. So yes. And it's because opposite sides are congruent. All right, so number 2 over here says the same thing. So I'm going to color in a couple of congruent marks for you guys so you can see this a little better. Can't tell, these are arrows. So these sides are parallel, and these sides are parallel. So we have a couple of reasons that this guy is a parallelogram. So it's yes. And notice that the diagonals bisect. So this is congruent to this, and this is congruent to that. But also, the opposite sides are parallel. Oops. All right. Okay, number 3. Top of the eraser appears to be a parallelogram. Find the values of x and y so that the side of the eraser is a parallelogram. So opposite sides up here, this is opposite angles. Notice we have a y here and a y here. We have an x, and then we have just a number. So we're going to put the y's together. Those are the opposite angles, and they're congruent in these two. So for the x, 7x equals 56. We're going to divide both sides by 7, and x is going to equal 8. For the other side, for our y side, we have 5y minus 26. It's going to be equal to 4y plus 4. All right, so we're going to subtract the 4y from both sides. 5y minus 4y is y. Negative 26 comes down, so does the 4. Add 26 to both sides. Y equals 30. Alright, so we can get all this in here. Alright, number 4, bottom of page 8. The mosaic pattern on the floor is made up of different tiles. Part A says find the values of x and y, so the tile is a parallelogram. So our opposite sides here, here's our x's, here's our y's. We're going to put those together and put them equal to each other because opposite sides are congruent. And just to stop before we go, we're going to prove that by solving for x and solving for y. But down here it's asking us to select the theorem. Notice that A says that opposite sides are congruent and the quadrilateral is a parallelogram. We're not looking at angles, we're not looking at diagonals, and we don't know about if they're parallel or not. So it's going to be that once we prove this. So let's put the x's together. 3x plus 4 equals 5x minus 2. And just kind of do here, the other side, we have 4y minus 9 is equal to 2y plus 5. So let's solve for x. Subtracting 3x from both sides. We got 4 comes down. 5 minus 3x is 2x minus 2. Add 2 to both sides. 2x equals 6. Divide both sides by 2. X is going to equal 3. And on the other side, we're going to subtract the 2y. These guys cancel. 5 comes down. Negative 9 comes down. 4 minus 2 is 2y. Add 9 to both sides. 2y is going to equal 14. Divide both sides by 2. Y is equal to 7. Are we off the page? No. A little picture in a picture is in my way. But I know you guys don't see that. Okay, flipping over to page 9. All right, top of page 9, number 5. Determine whether quadrilateral FGHJ is a parallelogram by using the midpoint formula. If it is a parallelogram, write a narrative proof. If not, justify your reasoning. We're not really going to have the space for the narrative proof if we need it, but we are going to justify it and we're going to state the rule. So we're going to cut a little bit of a corner here. All right, so, and what they mean by using the midpoint formula, if the diagonals here bisect, then they will have the same point. So if we draw a line, or if we take the points for F and H and find the midpoint and the midpoint for J and G, if they're the same point, then we have a parallelogram. If they're not, we don't. So let's plot our points. All right, so F is going to be -2, +4. G is +4, +2. J is -2, -1. Oops. And H is 4, negative 2. I'll just switch to a green pen. So, FH. Let's use the midpoint formula, see what that midpoint of that diagonal is. So our x's are negative 2 and positive 4. And our y's are 4 minus 2. And, quick reference, midpoint is x of 1, x of 2 divided by 2. And the y is y sub 1, y sub 2 divided by 2. Okay. So, for this, negative 2 plus 4 is negative 2. I'm sorry, positive 2 over 2. 4 minus 2 is 2 over 2. So the midpoint for this guy is 2 over 2 is 1. 2 over 2 is 1. So the midpoint for this is 1, 1. All right, so let's do JG in blue. So our x's are negative 2, positive 4. So that looks the same. 4 and positive 4, negative 2 make positive 2 over 2, which is 1. The other guy, we got negative 1 plus 2. Uh-oh, got a problem. Negative 2 plus 2, I'm sorry, negative 1 plus 2 is positive 1 over 2. So the point for JG is 1 and then a half. So, whoops. So not a parallelogram. Because our midpoints don't match up. All right, let's trickle on down here. Number 6. And this is, let me verify. Yes, this is the end of this topic. So, determine whether quadrilateral ABCD is a parallelogram. If it is, write a narrative proof. If not, justify your reasoning. So, again, we're not going to do the narrative proof, but we will state our reasoning. We have a few different ways we can find out whether or not this guy is a parallelogram or not. First, I'm going to plot the points. A is at 3, 3. D is at 1, 0. C is at 6, negative 1. And B is at 8, positive 2. So, we could use the distance formula to see if the opposite sides are congruent. Or we can check to see if the diagonals match up like they did in the problem above. So we're going to do that because it's a little shorter. So we're going to do AC first in blue. See, our x's are 3 and 6. So 3 plus 6 divided by 2. Our y's are 3 and negative 1. So 3 minus 1 over 2. 3 plus 6 is 9. 9 over 2 is 9 halves, or 4 and a half. 3 minus 1 is 2. 2 over 2 is 1. So the midpoint for AC is 4 and a half, 1. So 1, 2, 3, 4 and a half, 1. Well, let me do it in blue, excuse me. Okay. Excuse me. Now, BD or DB, we'll just say DB. X's are 1 and 8, and your Y's are 0 and 2. So 8 plus 1 is 9. 9 over 2 is 9 halves, or 4 and a half. 0 plus 2 is 2. 2 over 2 is 1. So the midpoint for this guy is 4 and a half, 1. So I'm just going to make it an X just so we can see it a little better. So those two line up, so yes. And it's because the diagonals bisect. And they bisect because their midpoints line up. So we don't have to do a narrative proof, but we can just show real quick here, yes, because the diagonals match up, because their midpoints match up. All right, that's it for this round, guys. If you have any questions, let me know. Till next time, have a good night.